Hello there, my name is Ahmed Hussein and welcome to my channel. In this video, I'm going to talk about how to protect your server in a Spring Boot application. Using Spring framework called Web Filter, filters in Spring Boot allow us to inspect and modify incoming requests before they reach our controllers. By the end of this tutorial, you will know how to create a custom filter that blocks unauthorized requests and protects your endpoints. So let's get started. As you can see in the screen, you will find that I'm creating a class already called filter component. And I extend another class called once per requests. So this once per request filter will be applied once for each request. So when a client trying to visit my backend or even trying to make a request through his client side, my logic will be applied here once. So each request will make me trying to figure out what this client trying to do to my server. So I just received the IP address of the client, but I can't relay on it. I mean, I can't use it as identifier because let's imagine this scenario. This client who tried to communicate with my server may be connected to a router that holds 10 people. And if I found or if I discover actually that this client trying to do a bad request towards my backend, it's unfair to block the other 9 people without doing any mistake. So I cannot rely on this kind of identifiers like client IP or even device ID for the client. Probably if you are going to create a front end, you will attempt to get an identifier from the client as device ID. The device ID can be faked, and there is a numerous application that can fake these kind of device IDs. So you don't have to rely on those kind of identifiers. In my opinion, you have to create a registration system, and this registration system will record the client who just signed up to your server. I mean, I will have a database and I will ask this client to give me some information. And if he try to change those information later, then we will have a problem. For me, this is the best practice to protect your server and especially to protect some sort of endpoints that will hold a special service that you are providing. So by using once per request filter, I'm expecting that this logic that I will apply here will be requested once. So each request will happen, this logic will be applied once. So one time per request. So I have to wait for some data from the client. I mean, I cannot make my endpoints open for the client to freely communicate with it. No, I have to wait for some stuff from the client. So what does this method doing actually? Add the same name of the method, get or generate cookie ID. So if my client trying to send a request to my server, I'm going to check his cookies. And if he got a value of my cookies that I already implemented down there, then I will get the cookie from his browser or even from his request because he have to send this kind of cookies to my server in order to communicate with my backend. So let me first print out this client token and let me open my developer tools. And inside my developer tools, I will go for my cookies so I can see what will going on in my browser. Let me show it to you in my OBS. So right there, you can see my browser and you can see my information here for the localhost cookies. And you can see I already have an API client ID, which is in my code. Let me show it to you. Which is in my code, I already identify this name. So I got a cookie name and I called it API client ID. So let me remove it. Let me try to remove this cookie from my browser. And let me delete this one. And if I try to refresh, you can see I will have an API client ID. So my code is working to generate a cookie for this client if his request missing this kind of value. So let me show it to you in my Spring Boot. So you can see also if I print out, let me restart the IDE. And you can see now in my console that there is a token has been generated. And when I refresh the page, the same token has been showed in my console because the logic of get or generate cookie ID is very simple and it's very easy. When the client sends a request, I just check his cookies. If I don't find my cookie ID, I just generate a new cookie value and I set it to his request. So if I find a cookie ID with the identifier that I specify, I would just return with the same cookie ID that I just get from his cookies values. So if my client don't have a cookies, I will only call this logic. If no cookies found, I will create a new cookie and set the cookie ID to the requester. When a client attempts to send the one request, I will try to get this client IP address and as well on his session, I'm trying to add a cookie to his session. Um, I just created a new cookie over here. And in my new cookie, I just set for HTTP only. If I'm using SSL or HTTPS to communicate with my server, I would set secure to true. So if I'm using SSL, I would set this secure to true. And the path, I just identify the path for all my routes. So all my endpoints have to get this kind of cookie ID. And I just set an age for my cookie. So when the age reach the number that I just added to my max age, so this cookie will be terminated from the user session or will be deleted from the user browser. And for now, I just use his response to add this cookie in his response. So in future, when he send the request, I will have this cookie among his requests. So it's very simple code and it's not a main way to protect your server. For now, this is a basic way to identify the clients who try to request or made requests to your server. But this is not an accurate way actually, and this is not the best practice you should follow to identify your clients. Let's imagine if this client already keep deleting his cookies from his browser. That means you will keep generating and cookies IDs and set it to his cookie for his new requests. And he will act like very anonymous client and you will don't know what this client trying to achieve actually. Maybe trying to make a DOS attack to your server or even trying to manipulate some part of your endpoints. But this is not the best practice to rely on. I mean, relying on client IP is not the good way to follow. Or even identifiers like device ID is not guaranteed actually to get the real device ID from the client because this client may use some softwares to change his client ID on his machine. So whether I'm using any kind of database drivers like MySQL or SQLite or Postgres, whatever, I will store his data that he will give me and later I will rely on this data to make the logic. For example, if I have a database and this database have a table and this table will call the client and this client table will have a records that I will relay on later. And I will force the client to send this data in order to process his request for some endpoints or maybe over all my endpoints. So he cannot risk by destroying his account because he's trying to manipulate my server. So that's everything about this tutorial for now. I just showed you how to use a filter in your Spring Boot project and how to create a component using a class called once per request filter. In the next video, I will show you how to create a registration system and using database inside your Spring Boot project. Thank you for watching and see you in the next video. Bye bye.